Are people aware that the increment of water pollution, specifically colour, has been vastly affected by the growth of F&B industry in Malaysia? Hi, Assalamualaikum. My name is Nur Izzati binti Muhammad Arifin. Today, I'm going to present a poster on my final year research project with the title Colour Removal from F&B Industrial Wastewater by using Acetylene Gas Production Sludge APS. In this technological era, the demand for F&B products has been increasing, linear to the growth of population in Malaysia. According to Malaysian Investment Development Authority (MIDA), the food processing sector comprises of about 10% of the manufacturing output in Malaysia. Compared to other industry sectors, this industry uses a colossal amount of water for every ton of product made by them. The uses of artificial colour and dyes in their production cycle has caused the wastewater coming from this industry to have a high concentration of unwanted parameters, specifically colour and chemical oxygen demand (COD). This may cause to the interruption of clean water supply to residential and other areas if the wastewater is not being treated first. Apart from that, artificial colour could affect the environment when sunlight could not penetrate through water with high concentration of colour. This would lead to the depletion of dissolved oxygen in the water and would definitely interrupt with the ecosystem cycle. Artificial colour could also affect the human health. They may cause human beings to experience irritation, mutation, skin and eye infections as well as cancer. Hence, it is very important to treat the colour from the wastewater to prevent harmful effects to human health and the environment. As a solution, previous studies have found that acetylene gas production sludge (APS) has the potential to be a good chemical precipitant in the wastewater treatment. This is due to the reason that it contains a high composition of calcium hydroxide, which is normally above 90% on dry wet basis. The calcium and hydroxide ions in the calcium hydroxide contribute in trapping the colloidal particles containing in the wastewater. There are several problem statements of this study. Currently, activated carbon AC has been widely used in the wastewater treatment. Despite its great performance, big budget is needed to use it. Additional chemical reagent like sodium hydroxide is also needed when using AC to treat the wastewater. Hence, industries are looking for other alternative methods and chemicals that could be as effective as existing ones, but is also much cheaper. Other than that, Malaysia has quite limited space for landfills, and APS is one of the scheduled waste coming from the industrial sector. Therefore, in line with the circular economy and cradle-to-cradle concepts, the reuse of APS in other applications could certainly reduce the amount of landfill waste. Lastly, limited study on colour removal has driven the study to be conducted, which mainly to focus on the effectiveness of APS in removing colour particles from the wastewater. In this study, the first objective was to determine the optimum pH value and contact time with the highest percentage removal of colour and COD. The second one was to compare the performance between APS and lime to treat colour from the F&B wastewater. The last one was to conduct an absorption isotherm study on APS through Microsoft Excel software by using Langmuir and Freundlich isotherm model. For the scope of study, the chemical precipitant used was acetylene gas production sludge APS taken from a factory located in Shah Alam. The F&B wastewater was taken from Nutrifresh F&B Industries in Jem Berhad. The characterization of F&B wastewater was done by using HEC-DR6000 spectrophotometer and UV spectroscopy, while the characterization of APS was done by using X-ray diffractometer XRD, X-ray fluorescence XRF, scanning electron microscope SEM, and Fourier transform infrared FTIR. The parameters being manipulated were pH value and contact time. The pH value was varied from pH 5 to pH 9, which mainly to comply with the allowable pH water discharge as stated in Standard B of Industrial Effluent Regulation 2009. Several series of jar tests were run at 120 rpm with contact time varying from 20, 30 to 40 minutes. In addition, the amount of APS dosing were depending on the desired pH value of the wastewater. Proceeding to the methodology of the experiment, after the APS was and wastewater was taken from the industry, the APS was first being dried by using oven at 100 degrees Celsius for 24 hours. The dry APS was cooled down to room temperature and then crushed by using mortar and pestle. The crushed APS was then sieved to get uniform powder size, which is 300 micrometer. The next step is the characterization of the raw material. The equipment used were the same as mentioned in the scope of study, including pH meter and turbidimeter. Next is the chemical precipitation process through jar test by using orbital checker. The pH was varied from pH 5 to pH 9, while the contact time was varied from 20, 30 to 40 minutes. Next is the analysis on percentage removal of color and COD, which was done to each of the beaker from the jar test. After that, the comparison between the users of APS and pure lime to treat the wastewater was done by using the optimal parameters obtained from the previous experiment. The optimal parameters are pH 7 and contact time 20 minutes. The last one is the adsorption isotone study on the adsorption capacity of the APS. The study was done through Microsoft Excel software by using Langmuir and Friendly's isotone model. For the result section, it is divided into 3 parts. The first part is the jar test result. Based on figure 1, it can be clearly seen that as the APS dosing increases, the pH value also increases. This is due to the alkalinity characteristic of the APS since it contains a high value of hydroxide ions in its composition. Apart from that, based on figure 2, the optimum pH value obtained for the jar test is pH 7, where the contact time was kept constant at 20 minutes. The percentage removal of color and COD at these optimal conditions are 99.5% and 89.8% respectively. This shows that the APS is able to remove almost 100% of color particles from the wastewater. However, the percentage removal of both color and COD decreases after pH 7. This can be concluded that excessive dosing of APS will only increase the particles in the wastewater, hence reducing its effectiveness. As for contact time, the optimum value obtained from the jar test is 20 minutes. The percentage removal of color decreases as contact time increases. This means that color particles cannot bind onto the APS for a longer time than 20 minutes. For COD, the percentage removal decreases at the contact time 30 minutes but increases back at contact time 40 minutes. Hence, a wider range of contact time should be studied on the performance of the APS in treating the wastewater. For the second part, Figure 4 shows the comparison between the FTIR analysis on APS and pure lime. It can be clearly seen that the trend of transmittance for both chemicals is similar. Hence, it is confirmed that APS can be an alternative chemical for lime. Based on the same figure, it is apparent that the highest peak of wave number for both chemicals is about 3,200 per centimeter. According to previous studies, this is due to the presence of OH bond coming from the calcium hydroxide, which is responsible for the color and COD removal. Based on figure 5, it is evident that APS was able to remove particles from the wastewater. This is because few particles left that could absorb the UV-based light, leading to the lower percentage of light absorbance compared to the untreated wastewater. And the last one, based on figure 6, the percentage of light absorbance for APS-treated wastewater is lower than the lime-treated wastewater. This shows that with the same trend of transmittance, pH value, and contact time, APS could perform better than lime in treating the wastewater, specifically color. For the last part, which is the adsorption isotone study, 2 isotone models were used, which are Langmuir and Friendly's isotone models. Based on figure 7 and figure 8, the R-squared values for color and COD absorption for both Langmuir and Friendly's isotone models are far from 1. The closest value is 0.88, which was still far from reaching 1. This means that color specifically could not be removed from the FMB wastewater through adsorption process. Hence, it can be summarized that the color particles was removed by APS through chemical precipitation process instead. Since all of the results have been discussed, a few conclusions can be made from the study. The first one is pH value increases as APS dosing increases. This is due to the alkalinity characteristic of the APS. The second one is the optimum conditions obtained from the series of jar tests were pH 7 and contact time 20 minutes. At optimum conditions, almost 100% of color could be removed from the FMB wastewater. The next one is regarding the adsorption isotone study. It proves that color particles from the wastewater was removed through chemical precipitation instead of adsorption process. To sum it up, APS can be used in the industry as an alternative chemical of pure lime due to their same trend of performance. In addition, actually APS can perform better than lime. Moreover, the reuse of APS in the wastewater treatment could certainly reduce the amount of landfill waste. Based on the result obtained from the study, there are some recommendations that should be considered to get a better result. The first one is a wider range of contact time should be studied, especially in determining the performance of APS in removing COD. The next one is the effect of APS powder size and the temperature of wastewater should be monitored to get a more accurate result for the performance of APS. The last one is different types of industrial wastewater should be used in the study in order to confirm the APS can be applied in the industry of wastewater treatment. Before I end my presentation, I would like to share my participations and achievements relating to this research project throughout the semester. The first one was participation in Majlis Pesanan Inovasi Shah Alam PISA 2021. The second one was the Innovation and Invention Competition, which was held in the conjunction of ICMCC 2021. My team won the 5th place and was awarded with Silver Award. The last one was my best achievement, which is the 5 minutes tech splash competition. I was deeply pleased and honored to be receiving the Gold Award and to be awarded as the first place winner of the competition. With that, I would like to end my presentation and thank you for your time.